Now we're going to multiply matrices. And I have set this top example up in such a way to where you'll be able to see what actually happens with it. So notice that we have I'll use a pencil here. We have a 2 by 2, and we're going to multiply it by a 2 by 1. And when I do, these two cancel for reasons that you're about to learn. And I get a 2 by 1, and it'll get simplified here. And so my final answer is, of course, a 2 by 1. This is just a simplification in the process. And here's how it's going to simplify. Check this out. I want to find the top number, the top number would be the first row and really the only column. So I'm going to circle with a pencil lightly the top row and the only column. And I'm going to write things in purple for fun. 4 times 3. 4 times 3. Yes, it's 12, but I don't want to just put 12. And then I'm going to add, and you'll see why this comes in handy on the word problem, -6 times -2. Okay? So 12 and then 12, so 24 is what I get. Now, why would I do that? It has to do with what these rows and columns represent. And again, you'll see it on the next example. But we just figured out top row, only column. So now let's go to bottom row, only column. Now, if we wanted to multiply, for example, let's back up for a second. A 2 by 2 with a 2 by 4, we would have a lot more work to do. But right now, we're just going to end up with 2 numbers to crunch. That's it. So I'm going to erase this top row. I'm going to circle the bottom row, and we're going to loop them together. We have looped the bottom row with, well, the only column, and that gives me -8 times 3, -8 times 3, plus, and then we're going to move to the next pair of numbers, and we have to have the same number of items in each list. That's why these two middle numbers had to match up, right? So like if I had 3 numbers here and 3 numbers here, I could do it. If I have 3 numbers here in this row but 2 numbers in this column, I can't do it. Okay, -8 times 3 plus, let's move to the next, 1 times -2. That gives me -24 minus 2, and that, my friends, is going to give me -26. We have just multiplied matrices together. Aren't you excited? Okay, now we're going to jump into a word problem that really drives this idea home. I'm going to go kind of slowly and write big. The AHS Athletic Boosters are running the concession stands at the JV football game. They sell cans of soda for $1, slice of pizza for $3, chicken sandwich for $5, and candy for $1.50. The home side has this, and the visitor side has that, and then, oh my goodness, I'm already overwhelmed. Let's just read the directions. Write a matrix that represents the price and the type of candy. And this will be matrix A. So matrix A is going to be, I'm going to just put an A right here, and then I'm going to write the matrix below it. I think it's the best way to represent it. We're going to have the price as the rows. Let's just stop and think. Price. That's just like one thing. So we're just going to have price here. Price. Okay. And then the type of candy. Well, how many different types of candy? And when I say candy, I'm referring to how many different types of things. I should not have used the word candy, but I mean how many different types of things. So I have soda, pizza, sandwiches, and actually candy itself. So soda, pizza, again, I should not have used the word candy here. Chicken sandwiches and actual candy. And if you want a little more clarification, I'm going to take the word candy out of these two questions, and instead I'm going to put food or drink. Still not completely clear, so food or drink and food or drink here. So there we go. All right, so we are making matrix A right now. And matrix A is going to be the price of soda. Well, the price of soda is $1. The price of pizza is $3. The price of a chicken sandwich is $5, and the price of candy is $1.50. There's matrix A. We have just dealt with that question. Now let's go to this question, which asks us to write matrix B. And it represents the type of food or drink as the rows, and the concession stand is the columns. Well, okay, well, how many different types of food or drink do we have? We have 4: soda, pizza, chicken sandwiches, and candy. So we're going to list those down this side. So soda, pizza, chicken sandwich, and candy. And then the concession stand. How many concession stands do we have? Well, we have 2. We have home and we have visitor. So you have to read very carefully. We have home and we have visitor. And then we start filling in numbers. So it's common sense at this point. You just have to know where to look. Soda, home. The home side of the concession stand sold 160 cans of soda. They sold 82 slices of pizza. They sold 103 chicken sandwiches and 72 pieces of candy. Okay, visitor side sold 102, 65, 52, and 37. Be careful if the numbers are in a different order. All right, I want you to notice what happened here. We have just made a 1/4 matrix, and we're going to multiply it. Matrix multiplication to determine the profit for each concession stand. We're going to multiply it with a 4/2 matrix, and that's going to give me, notice the 4s are going to cancel, and I'm going to get a 1/2 matrix. My final answer is going to be a 1/2 matrix, and my 1 row is the price. It's actually going to turn into profit, and my 2 columns are going to be home and visitor. So I will know the profit on the home side and the profit on the visitor side. It's going to be very, very handy. So let's do it. Switch colors here. My product of A times B, I'm just going to write that. This is going to be A times B. And you could just call it AB. That works too. Is going to be, again, a 1/2 matrix. 1 row and 2 columns. And my first row, first column is going to go here, and my second row, second column is going to go here. And if you're wondering, why did I make those big gaps? Because I'm going to be writing a whole bunch of numbers here. So this is A times B, and again, this is, I would call it price because it is the price, but it's money at this point. So we are turning a profit. So it's dollar amounts. That's basically the same kind of representation. And this is going to be home, and this is going to be visitor. And I'm about to switch colors one more time and write some numbers in here. And here's how it goes. My row, only row, and my home column are going to go together. This is going to make so much sense once you see it. $1 per soda for 160 sodas. So 1 times 160. Put 160 if you want to. I'm going to put the 1. Plus $3 for every pizza times 82 pizzas. So 3 times 82. Plus $5 for chicken sandwich times 103. 5 times 103. Plus $1.50 for candy times 72 pieces of candy or bags of candy or whatever. $1.50 times 72. I'll grab a calculator in a moment and we'll figure that out. That's the home side. Now the visitor side. Prices remain the same, but now we will come over here. We're going to do it with the visitor side. So $1 for a soda times 102 sodas. 1 times 102 plus 3 times 65 plus 5 times 52 plus $1.50 for a piece of candy and 37 candies. All right, in just a second, we are going to have a matrix that will show us the entire profit that was made on the home side of the concession stand and the entire profit that was made on the visitor side of the concession stand. And that will be this right here. And we're going to have, once again, our two numbers, but I'm just going to simplify things quite a bit. Grabbing a calculator. And when I do, that will clear everything up. 160, 3 times 82, 5 times 103, and 1.5 times 72. By the way, calculators will do the entire matrix operation for you. And there's also a great program online. It's called, well, it's Desmos. Desmos.com/matrix, and it will do it too. And we will delve into that at another time. In the meantime, if we don't know how to do it by hand, we don't understand the concept from where this is going. So 612.50, we'll put 2 decimal places on that because it just makes sense. Get it? There we go. We know the profit that we made on the home side and the profit that we made on the visitor side by multiplying the price times the quantity and then adding the items together using just the properties of matrix multiplication.